Howdy, I'm Matt, Chief of the Flutter Bounty Hunters, and today I want to talk to you about a very important concept in open source development. Really an important concept in all development, but especially open source, and that's readable code. Let's jump into it. Readable code. In my opinion, readable code is the most important aspect of your code. Now, some developers will take issue with this. They'll say, no, it's all about performance, or it's about avoiding bugs, or this metric or that metric. I think that's all a mistake. If code is easily read and understood, and I include in that the idea of intention, what do you intend to do? If that's obvious, then you can find bugs and you can fix them. If the intention is obvious and the way the code works is obvious, you can refactor it to gain better performance. Obviously, tests are a part of that as well. But then again, are your tests readable? Do the descriptions make sense? Can you tell what a test is trying to test? It all comes back to readability. Readability is really a word about how you communicate with your team members, both your team members today and your team members sometime in the future, or even how you communicate from the version of you today to the version of you a week, a month, a year from now. So let's take a look at what I think about when it comes to readable code. These are the topics that to me are at least the most important. Readable code is kind of an art, so we could talk about it for days, but to me, these are the big ones. Documentation, code comments, how you name things, how you order things, and how you handle your test descriptions. We're going to walk through just a few thoughts and examples on each of these, and then you'll have a head start to writing more readable code. Documentation. Write great doc comments and code comments. When I say doc comments, I'm referring to Dart docs. Those are the comments that appear on top of your class names or your public functions. They get automatically turned into documentation when you generate API docs. And then code comments are all the other comments that you put in your code. It's important to remember when working in Flutter and Dart that the first sentence of your Dart doc is important. Because if let's take a look at generated Dart docs here. This is from Super Editor. Now you'll notice right off the bat, by the way, that some of these classes are missing Dart docs, and that's not good. When you say, oh, my class name says everything there is to know, just remember that when you generate the docs, it's going to look very bare. Delete paragraphs command, that might be a great name, but it kind of feels like it's missing something here, right? It would be at least comforting as a reader to see some kind of description for delete paragraphs command and delete selection command. It's much nicer to see the examples below, like document and document composer and document editor, each of which tell us something. But also notice that each of these classes that include some documentation, all we ever see is the first sentence. This is part of how the documents are generated. When you're looking at a list of classes or a list of methods, you only ever see the first sentence. Everything else is elided, and then you can either click into the class or you can click on the ellipsis to see more. But this means that often the only thing someone's going to see in the docs is the very first sentence of your documentation, so you need to pay extra special attention to that sentence. You want to find a way to describe the overall purpose of your class or your method, but in a relatively concise manner. And then, if needed, you can add more beneath that first sentence, but you got to get that first sentence right. So always pay attention to that. Now, when you're writing Dart docs for classes or methods or anything else, always try to predict the questions that the reader will ask. Remember that your documentation is intended to be read. Like, the entire purpose of it is that somebody else is going to come along later who knows what they know and what they don't know, They're going to read your documentation, and that's going to establish their understanding for what the code can do. Just think about how many times you've opened up the Flutter Dart docs and you've read the Dart docs, but you didn't read the source code. That's probably most of you, most of the time. You only crack open the source code when you need to. So you expect that documentation tells you quite a bit about what's happening and why and how. That's now your responsibility as someone who's working on an open source package. Flutter is an open source package. Now you're working on an open source package. You have the same responsibility. The documentation that you write needs to provide a pretty strong understanding of the code, even when the developer doesn't jump into the source code to read what's actually happening. Part of that challenge is to establish in your mind what you think the reader probably knows and what the reader probably doesn't know. You also need to consider, regardless of what the reader knows, what is likely to confuse the reader. Let's look at an example of what it means to try to predict these questions. Let's look at the documentation for document. This again comes from SuperEditor. There is a class called document, and what you're seeing here is the full class description. What you're seeing highlighted in red, every one of these statements, is essentially me predicting that you, the reader, will have a certain question, and I'm going to answer it. I'm going to jump in and say, I know you're probably wondering this, so here's the answer. Let's read through this together. The first sentence summarizes what a document is: a read-only document with styled text and multimedia elements. That's the sentence that makes it in to the abbreviated documentation in the generated docs. But then I start answering questions that you might be asking. For example, what is the structure of a document? What does it mean to be a read-only document? Well, a document is comprised of a list of document nodes. That's the structure. Now, we don't know exactly what a document node is here, but we now know that a document is essentially a glorified list. It's a list of these things called document nodes. Next, new types of content can be added by subclassing document node. If you're in here looking at the definition of document, there's a decent chance that the reason you're here is because you're introducing a new type of content that you want to work inside of a document. What do you have to do? Well, you have to go subclass document node. And how about representing a specific location in a document? So obviously you have those nodes, but then there's different content within nodes. And how do you point to a specific location or place in that content within a node? That's answered right here. To represent a specific location within a document, see document position. You might be wondering about visuals. In fact, maybe you opened up document thinking that this was a widget. Now, if you know the overall structure of the package, you wouldn't do that. But again, who knows how you got here? You may have just opened up the API docs, clicked on the thing called document thinking it was a widget. So we have this line near the bottom that says a document has no opinion on the visual presentation of its content. That should make it clear to you that if you're interested in widgets, layout, anything visual, you are in the wrong place. And then finally, to edit the content of a document, that's obviously of interest because at the very top it says this is read-only, and you're using SuperEditor probably to create a document editor. You want to change documents. What am I supposed to do? Well, the last thing we say is to edit the content of a document, see document editor. In each of these lines, I am predicting what I think you might ask. And I haven't, it's not like I've predicted every crazy weird question. I haven't written an entire textbook here, but I've come up with what I thought are probably the most common questions that you are likely to have when you read this documentation. And I've tried to solve those problems for you. This is something that every developer should try to do. And you might even be surprised that when you start answering these hypothetical questions, you discover mistakes that you've made. you start realizing that you've included stuff in here that you shouldn't, or you've failed to include stuff in here that you should. So that's a kind of a secondary effect of effective documentation. You will actually discover some of your own mistakes and mishaps. All right. Now, when you're writing documentation, something that I often do a 1-2 punch. I start with a generic statement, and then I follow up with a concrete example. The generic statement is kind of the programming explanation, because we're always working in terms of rules and types and relationships. So I describe the generality. But a generality often doesn't make sense without a concrete example. But once you see the concrete example, you fully understand the generality. These two things should often go together. And again, we can go back to document and see an example. In that second paragraph, I start with the generality. The generality is a document is comprised of a list of document nodes, which describe the type and substance of a piece of content within the document. Now, that on its own, I'll admit, sounds pretty ambiguous. It sounds pretty wishy-washy. But then after that, I say, for example, a paragraph node holds a single paragraph of text within the document. That really solidifies the first statement. And now when you go back to the first statement, it makes a bit more sense. If all we had was the example, that probably wouldn't be enough. And if all we had was the generality, the general description, that leaves you a little bit confused. But bringing those two things together, you have a really firm grasp on what a document is, both generically or abstractly and concretely. So when you're describing something, consider that 1-2 punch. Where it makes sense, describe the thing abstractly and then drive it home with an example. You'll see a lot of that in the super editor documentation. Also, leave breadcrumbs for related tools. Always think about what the generated docs will look like. Again, going back to document, obviously you already noticed these links, but now I'm going to call them out explicitly. Every one of these links were a place that I put in square brackets so that the documentation would link to those other classes. And I referenced those classes because I knew that if you're going to work with a document, you're very likely going to work with a document node, a document position, and a document editor. I am helping you get to where you're going. Even here in the document class, this may not be where you want to be. So what are some other places that you might be looking for that I can help you get to? Are you starting to see how documentation in and of itself is an entire product? It's an entire service. Think about the reader. Think about the value that you can provide based on what you document and how you document it. Now, in terms of code comments, there could be all sorts of rules that we discuss in terms of code comments, but one of the biggest things is leave a comment any place where you're doing something unusual. That's really the key. We could write prose for every line of code. We could translate every line of code into some English description. Obviously, that's not a good use of our time. And most developers will understand most code as long as your naming and documentation makes sense. But sometimes you do things in code, and they might make total sense to you when you do it. But if we got a bunch of developers together, you'd find that those developers don't really understand why you did that or how you did it. And let's take an example. This code here, you and I could read this code and we can understand literally what it's doing. Like, we could very carefully inspect the lines of code and what they're doing with the CPU and what they're assigning and looking up. So if should prepend placeholder, then this variable prepended placeholder is set equal to this thing called leading character, whatever that is. Then we write out that placeholder, and then we update a character count. And then if we don't prepend a placeholder, apparently we just set the placeholder to an empty string. I've told you what this does, but you have no idea why we're doing it. Now, maybe up above, there's some method name that makes it clear. Maybe there's a documentation on that method. But this snippet of code is still a pretty good example where we should explain why we're doing this thing. This is kind of weird. This is not expected. The code itself does not really tell us why we're doing this. This can use a little bit of human grammatical English intervention. And so now let's take that same code and let's add a comment. The comment reads, put an arbitrary character at the front of the text so that the IME, input method engine, will report backspace buttons when the caret sits at the beginning of the node. For example, remember that 1-2 punch, generic, then specific, generic, specific? For example, the caret is at the beginning of some text, and we want to combine this text with the text above it when the user presses backspace. And then I show a literal example where we have 2 lines of text, which is like 2 paragraph nodes, text above, and then the selected text node, and that vertical bar represents the user's caret. Now, you still may not know exactly what this means. Probably if you were working in Super Editor, you would, but maybe you don't. You likely have a much better understanding, though, of what we're trying to do, because suddenly you find this reference to backspace buttons. This has something to do with pressing backspace, and it has something to do with the input method engine, and it has something to do with being able to cause a backspace change when you're at the beginning of text. You may not know how all those pieces really tie together, but you probably didn't know any of this before the comment. So we're doing something a bit unusual here, something that you may not expect. In fact, many developers have posted questions on Stack Overflow and elsewhere about why they can't respond to their mobile keyboard delete key when there's no text in the text field. Many developers don't understand this fact about input method engines. So we really drive this point home. We're not going to expect that you know all of the tricky stuff. We're going to describe the tricky stuff as we go, because our job as developers is to make our code easy to understand for the next developer who needs to read it. Now, naming. Name with purpose. Classes, methods, packages, files, directories, everything. Every name should have a purpose. Every name is a choice. Every choice you make should make things better instead of worse. Now let's start with names you should not use. You should not call things managers, helpers, utilities, data, models. All code manages something. All code helps you do something, otherwise it shouldn't exist. Same with utility. All code is being utilized for a purpose, otherwise you should delete it. Most code involves some amount of data, and everything you do in software is software modeling. So calling something a model doesn't really say anything. Now, there may be very specific times and places where you give these names a meaning. For example, perhaps model is used specifically and exclusively for data structures that come back from your server. If that's how you use the term model, and everybody on your team knows that, and everybody follows that rule, okay, that's a situation where you've carved out an exception. You do you. But in general, if you look at many projects and many programmers, there's nothing consistent about these names at all, and therefore they mean nothing. If there is no consistency in names, then the words don't have a definition. If they don't have a definition, they aren't communicating anything. In fact, they're just confusing people, because you call something a manager, and I think I know what you mean because I also call things managers. But it turns out that my definition is different from yours. So now I'm going to make assumptions that are false. It would have been better to not use that word at all and force me to go look something up, because you and I don't mean the same thing when we say manager. So these are words to be avoided. In Flutter Bounty Hunter code, I don't expect any of these to ever be used. Again, unless we're on a very specific project where we have a discussion about something like model or manager, maybe there's some unusual situation where we use them, but probably not. And helper and utility, never. Why are you writing code that doesn't help? These are silly names. People talk about helper functions. What is a helper function? Are you writing a bunch of functions that don't help? These are silly names. People use these names when they don't want to put in the effort to think about what they're actually describing. Now, over on the right is the word controller, and there's also a big red asterisk next to controller. In general, in programming in general, I recommend that you don't use the term controller for the same reason that you don't use the term manager. It means different things to every developer, and there's no consistency. I mean, there are controllers in MVC, Model View Controller, and then there are controllers in web frameworks like Ruby on Rails that have nothing to do with MVC. And then there are controllers that really just represent an object that talks to other objects, and you couldn't think of a better name for it, so you call it a controller. No consistency at all. Except in Flutter, the Flutter project itself uses the term controller to refer to something that actually is specific. Any object that crosses the widget boundary, any object that shares access and control of a widget, both inside the widget and outside the widget, is called a controller. Now, what do I mean by sharing access and control? Consider a text field. Obviously, a text field internally updates the text in the text field, and it updates the user selection. When you tap on a text field, you don't handle that. The text field handles it. So clearly, the text field needs to control the text and the selection. But from outside the text field, you still need to be able to query the text. And you also, from the outside, sometimes need to change the text, and you need to change the selection. So inside of text field and outside of text field, you need to be able to manipulate the text and the selection. Therefore, you have a text editing controller that you pass into the text field. The text editing controller actually owns the text and the selection, and both the text field widget and your state object both use the text editing controller to manipulate what's displayed in that text field. That's a controller. There's also a scroll controller, I think a page view controller or something like that. There are many different controllers in Flutter, but they all have that rule in common. They are the go-between between the inside of a widget and the outside. If that's what you're modeling in Flutter, you absolutely should call it a controller to match everything else in Flutter. If that is not exactly what you're modeling, do not call it a controller, because then you're lying to people, because Flutter developers have a certain expectation for what a controller does. All right. Here are some names at random pulled from Super Editor, because you may be asking, well, if those are bad names, what are better names? What should things be called? I don't have a big rule book for you, so I'm just going to give you some examples. And looking at these names, notice that you won't find manager, utility, helper, data, model, or controller anywhere in here. We have document. Now, document has data for sure. We could call it document data, but why would we do that? A document models a document. That is an abstraction of a document. It is a software model. We could call it document model, but why would we do that? Calling it document is just fine. Then we have document selection, document editor, document composer, paragraph node, image node. Over on the widget side, we have document mouse interactor, we have document keyboard interactor, we have super selectable text, and then we have attributed text is not a widget, that's also a logical class. We have attributed text as well. Now, of these names, probably the only word that we could actually remove without harming the names is the super in front of super selectable text. And the only reason super is there is because Flutter already includes a selectable text widget, and I didn't want you to constantly have to deal with naming conflicts. All the rest of the names actually need every word in the name. And there are also some patterns started here. So in paragraph node and image node, they both end with node. Now you might think maybe we could get rid of node. Just call it paragraph and image. And it's not a terrible idea, but the reason node is there is because we also have paragraph components and image components. What's the difference? A node is logical, it's part of the document. A component is visual, it's a widget inside the document layout. To make that abundantly clear to everyone, every document node ends with node, paragraph node, image node, horizontal rule node, list item node. And then each component ends with component, paragraph component, image component, list item component. That was a trade-off. Yes, there's an extra word, but the moment you see the name, you know which part of the editor you're dealing with, logical or visual. Also, over with interactor. Now, the term interactor in general doesn't mean anything, but I've created a pattern here where once you understand how that word is being used, it becomes useful. Both document mouse interactor and document keyboard interactor are widgets without any visuals of their own. They have no visuals. They are widgets that introduce the behavior that handles user input. So the document mouse interactor, it doesn't know how to lay out a document. It doesn't even know what exactly is inside of it from a widget perspective. But it does intercept taps, double taps, triple taps, drags, and it reacts to those things against a document. So I mean, it has a reference to a logical document. It can change the selection of the document. But that widget itself doesn't know how to render a document. It just includes the gesture detector that knows how to manipulate the document. Very similar for document keyboard interactor. All that widget does is add a focus node. That focus node listens for every single key that you press on your keyboard and applies appropriate actions to a document. It doesn't know how to render a document. It doesn't know anything about document layout. It just knows how to do the user interaction part. So even though one of those is about the mouse and the other is about the keyboard, that word interactor now starts to mean something, and now you know what to expect. Like, you shouldn't go into a document keyboard interactor looking for the document layout. You're not going to find it. That's an interactor. It's non-visual. It's just about dealing with the input. The important thing about names like that is you have to keep them consistent. You need to make sure that every time the term interactor in a project is used, it means that same kind of thing. All right, write your code in order to be read. We are humans. We read things from top to bottom. Most of us read things from left to right. As with naming, as with documentation, you control the order that things appear in your source code files. Many developers ignore this, but you shouldn't. Anything you control, you should use to your benefit, including the order that you define things. Let's imagine that you want to implement something to create a pizza. And let's see if is this order of code something that's useful to you. If you didn't write this code, but you're coming in, you have to read it, you have to find a bug. Is this a useful order to define these methods? Flatten dough, prepare sauce, preheat oven, make dough, bake pizza, assemble pizza, make pizza. And just in case you didn't notice, the very last method here is the only public method. The thing you're actually calling publicly is at the bottom. It's called make pizza. Now, this is literally a random order of methods because I literally just randomized this. And so there's nothing reflected in the order here. That's what random means. There is no order to it. You can glean nothing by the order that these methods are declared. And by the way, the one method that is the entry point for you, the public developer, is at the bottom. It's pushed below everything else, and yet that's probably where you want to begin. Now, some developers would say, oh, well, we can just alphabetize all of these methods, because then we know exactly where a method goes, and then it looks something like this. Now it's assemble pizza, then bake pizza, then flatten the dough, then make dough, then prepare sauce, then preheat oven, then make the pizza. I've never understood alphabetizing methods. The only way that an alphabetical list of methods is useful to you is if you already know the exact name or almost the exact name of the method that you're looking for. But if you already know that, you have IDE shortcuts. Just press the Shift button twice, type in part of the name, and the IDE will find what you're looking for. If you're reading code from top to bottom, you're not there for lookup, you're there for exploration. You're trying to understand what is going on and why is it going on and how is it happening. You are trying to comprehend large swaths of code. In that regard, alphabetized methods tell you nothing. The alphabetical location of the first letter of a method name means nothing about the significance of the code, not the intention, not the implementation, not anything. Yes, it tells you exactly where to stick a method, and then it's absolutely useless what you've done with the order of your methods. So alphabetizing to me seems very silly, and I don't think we should do that. In this case, it's very obvious what order these methods should be. You begin with your one public method, the one method that everybody knows exists, the one method that's going to lead everybody into this file. And then you order every private method roughly in the order that it's called. First, you preheat the oven. Then you prepare sauce. Then you make dough. Then you flatten dough. Then you assemble pizza. And then you bake pizza. If that's the order that these things happen, then why not declare them in the same order? And maybe the order of these things changes at some point, and then you can change the order that the methods are declared. The point is, you have the power of method ordering, and you can order these methods so that they immediately make more sense to the person reading it instead of less sense. You should use that power and that opportunity. Now, not everything is making a pizza, and not everything is going to make sense like this, but I'm trying to guide you into thinking about this issue of order. If there is a clear and relevant temporal order, if execution order matters, and you decompose one method into other methods, why would you not declare those methods in the order that they are used? On a related note, even if we kind of remove order of execution from this, generally it makes sense to have higher level methods at the top of a file and lower level methods as you go down. So as this gets a little, we'd probably have to see some very specific examples to really cover the gamut here, but your execution is essentially a tree. You might start from one method and then go to 2 or 3 from there, and each of those go to 2 or 3 from there. Any method that you call should be defined below the method that calls it, when possible. We're just talking about heuristics here. But for example, make pizza here calls all these other methods. So these methods appear beneath make pizza. And then if preheat oven called another method of its own, and it was only called by preheat oven, that method could go right beneath preheat oven. Now that ordering isn't perfect, because what we're essentially doing is taking a tree and we're turning a tree into a list. There's no perfect way to turn that tree into a list and keep all the details. But if you generally follow the rule that any method you call from, anytime that method A calls method B, then method B is defined beneath method A. If you try to kind of follow that in general through all of your code, you're going to be in decent shape. That's at least better than doing the alternative, right? Which is defining methods up at the top that are called later towards the bottom. That's the opposite of your reading order. That's the opposite of the way at least most humans digest information. So don't do that. I'm just trying to guide you towards a way of thinking that more often than not will create an order of declarations that are easier to read instead of more difficult. Be consistent. So if you're dealing with the same kind of situation over and over again, like make pizza, that's a unique thing. We do not implement pizza creation on a regular basis. So for that problem, we stop and we think about what should the order be. But certain classes and interfaces we implement all the time, and they involve the same kinds of details. We should be consistent. It's more useful in those cases to be consistent, that every time you open up that particular kind of implementation, you know roughly what order things are going to appear. For example, we implement a lot of state classes. Every stateful widget includes an implementation of state. And generally speaking, we can break down that implementation into 4 pieces. Some of these pieces might not be there for simple state objects, but what you see before you is a breakdown that pretty much any state object can conform itself to. There are many different ways that you could choose to order state objects. What you see in front of you is how I order them. This is how I expect them to be ordered in Flutter Bounty Hunter projects. But if in your own projects and in your own teams you feel strongly about a different order, you do you, but you might consider that whatever you do, it be consistent. So what is the order that I expect in Flutter Bounty Hunter projects? I expect to begin with all property declarations at the top. Property declarations give you a little bit of insight into how complicated this object is, some of the interesting things that it might do, without actually getting into a bunch of implementation. But then after properties, I expect to see the lifecycle methods declared in roughly the order that they are executed. This goes back to the make pizza thing. Lifecycle methods have a very strict order. Now, it's not always linear. For example, whether you put did update widget above or below did change dependencies, that's kind of up to you because those can be executed at different times. But they are definitely executed after init state, and they are definitely executed before dispose. So where the order is clear, you should honor and respect the order. This allows developers to read the life of a state object, the whole life, in the order that it's likely to occur. Now, I'm not saying that the reader is going to understand the meaning of everything in those lifecycle methods because the reader hasn't gotten to the other half of the class yet. But lifecycle methods are often about initializing something in one place and then cleaning it up somewhere else. By putting all the lifecycle methods together, you can pretty easily coordinate when things are created, also when they're updated, and when they're cleaned up, and you can see it in the order that those things happen. That is useful when reading state object code. Beneath the lifecycle method comes all of the non-widget methods, all the methods that you add to the state object that do not build widgets. Those are, all of your tap and drag handlers, for example, maybe form validators, all that kind of stuff. Put it right there after the lifecycle methods. Then come the build methods. Now, build methods plural might confuse some of you. You might say, well, isn't there just one build method? And publicly, yes. In the official contract, yes, there's just one build method. However, far too many Flutter developers stick far too many widgets in a build method from a readability standpoint. I'm not talking about performance. Just from the ability to understand what the heck is going on in your widget tree, you stick way too many widgets in that widget tree. There are multiple levels of concepts in your widget tree, in many of your widget trees, in your state objects. What you should do is decompose that widget tree. Now, some people think that every time you decompose your widget tree, you should create new stateless widgets. I do not believe that. I think that the Flutter community has been misguided on this. I'm not saying you should never do that, but I completely disagree that you should always do that. That's not the debate that I'm going to have here. Instead, I'm going to point out that in the code that I write, and perhaps in the code that you contribute, there may be many places where you build pieces of your widget tree using private methods like what you see here, build app bar, build list item. Those are private methods. They should be defined beneath the main build method. And why is that? Well, once again, the main build method is the highest level. The main build method is the one that calls all the build methods below it. And you can imagine here that build list might be the method that calls build list item. That's something we can infer just based on the order. In fact, if we look at build app bar, build list item, without a single line of implementation here, it looks pretty clear like, what we're building. You've got a pretty good hint just based on the method names and their order, what we're building and how we're building it. That's the power of naming, and that's the power of declaration order. Anyways, back to the high level. Properties followed by lifecycle, followed by your custom behaviors, followed by build methods. This ordering can apply to pretty much any state object, and it pretty much does apply to every state object that I've ever written. And if you contribute to the Flutter Bounty Hunters, this is the order that I would like you to honor. Now, here's just a very minor example to drive the point home. Let's say we create a custom state object. We do something in init and dispose. This one doesn't have any properties. That's uncommon, but whatever. This one doesn't have any properties. All we build is a gesture detector, and that gesture detector calls our own private onTap method. Even though this is a very bare bones example, this example honors the ordering that we just saw in the previous rule. All right, write great test descriptions. Test descriptions, test names, same thing. The part in the string that you put in as the first argument in your test. Let's just look at some examples. Here's a group of tests that are related to multi-tap gesture recognition. Now, probably that group name should be multi-tap gesture recognizer. That would make it a little more clear. But let's look at what works with these test names. So first, groups are a great tool, and you should make sure that you use them. Rather than start every single test name with multi-tap gesture, we yank that out as a group because that's what all of these tests are related to. But when Flutter runs these tests, the group name is combined, well, from your perspective, the group name is combined with the test name. It all becomes one big description. Let's read these. Multi-tap gesture can report preceding gestures. Multi-tap gesture reports single tap after timeout. Multi-tap gesture can ignore single tap gesture. Multi-tap gesture can ignore single tap and double tap gestures. Without looking at a single line of implementation, you've got a pretty darn good idea what we're testing and why we're testing it. Now, if you've never looked at a gesture recognizer, maybe some of this, maybe you don't know why it's all that relevant. But I will tell you this, if you looked at the implementation of these tests, if these names weren't useful, the test implementations would confuse you a lot. These are weird tests, and there are many lines of code in these tests because there has to be. No individual line is very complicated, but there are a lot of lines, and those lines are very carefully choreographing things that aren't clear without these names. Like we're talking about timeouts, for example. So report single tap after timeout. You can expect some manipulation of time, and now you know it's related to a timeout. Ignoring single tap gestures. Maybe you look at the code and you get to the expectation and you don't know why we're expecting what we're expecting. Well, the answer is we want to make sure that something is ignored. Test descriptions are incredibly important. If you have really great test descriptions, then someone could come along, erase the entire implementation, and you could still go back and re-implement the test without issue because you understand what is being tested and why it's being tested. If you don't provide great descriptions, then that isn't true, and your tests begin to rot over time, just as much as your code rots. Tests are arguably more important to explain than your source code, because if your source code gets screwed up, at least you have tests that show you what got screwed up, unless, of course, your tests have terrible descriptions, in which case you're just screwed. All right, another example. This one is a group within groups, so apparently list items have a lot of different responsibilities, and one of those is node converting one type of node to another. And here we have test converts paragraph with one dot space to ordered list item. Now, we actually could do better with the group naming here, because when we combine it all into one, it's not as much of a grammatically correct statement. It would read list items node conversion converts paragraph with one dot space to ordered list item. Okay, we could do a little bit better than that. But at least the test name converts paragraph with one dot space to ordered list item. That captures a lot of information. We're starting with a paragraph, then there's some pattern. We've given you an explicit example, and the paragraph is then turned into a list item. Once again, we could delete the entire implementation of the test, and you could re-implement this test, and you'd probably do it just fine, because the test description tells you what we're doing, and it's pretty clear why we're doing it. Here's another example. There are going to be some things in this example that are good and some things in this example that aren't so good. But let's take a look. The group, document keyboard actions.dart. That's the first thing that isn't very good. I should not have named this after a file. I don't know why I did that. It was not a smart thing to do. We should have started with some kind of subject, something related to behavior. And then group, command plus A to select all. Decent group name. Now here again, when we combine these statements into one, it's not such a great English sentence anymore. This is an area where we can use some improvement. The angle I was taking here was more of a Java unit testing angle, where names aren't collapsed down. And so from a unit testing angle, saying it does nothing when meta key is pressed, but A key is not pressed, that as an isolated test name is reasonable. But in Flutter and Dart, of course, we combine names. So what I should have done was come up with a better group name at the top and then put together an English sentence if possible. Nonetheless, what I just read to you should make pretty much perfect sense. If we're within a group called Command A to select all, whatever that behavior is, it should do nothing when the meta key is pressed, but the A key is not pressed. It's Command plus A, not just Command. Similarly, it does nothing when A key is pressed, but meta key is not pressed. That's checking the kind of the inverse. It does nothing when Command A is pressed, but the document is empty. Because if the document is empty, there's nothing to select. And then finally, it selects all when Command plus A is pressed with a single node document. Now, the fact that it's single node may not be important. It depends if there are more tests below that. Each of these names is very clear. This is the kind of clarity you want to achieve. The group name at the top is not great. It should be different. The connection between the group names and the test names is not great. I should go back and refactor this into more of an English sentence. And third, we have inconsistent terminology in the test names where sometimes we say meta key and sometimes we say CMD for command. We should make that consistent. Probably the easiest thing is to just always use CMD. But if what we mean is the same thing, there's no reason for us to be inconsistent. There's no reason to say CMD in one place and meta somewhere else. If what we mean is the same thing, we should have the same terminology because that's how we communicate. All right. And the last thing, for those of you that are working with the Flutter Bounty Hunters, be malleable. Your process might not be exactly our process. We might ask you to change how you do things a bit. We may ask you to order things and name things in ways that you haven't done previously. But that's part of working with a team. The important thing is that we work the same way whenever possible, that consistency part, that we have similar documentation strategies and practices, that we think about naming in a similar way, that we write test descriptions that tend to read like any one of us could have written them. Allow yourself to conform to the process of the Flutter Bounty Hunters when you're working with the Flutter Bounty Hunters. But also be malleable in the sense that those who are reviewing your code might also make mistakes. I might make mistakes. I might ask you to change a name or a description that we then come back later and say, you know, actually what I asked you to do wasn't that great either. Let's take a third stab at it. None of us are perfect, and we're all working under time constraints, and that tends to result in mistakes. Let's both do the best we can. You do the best you can to put up pull requests that require as little review as possible, pull requests that require as few changes as possible, and I will do my best to review your PR and only request changes one time. With that, hopefully we can work well together as the Flutter Bounty Hunters and deliver great open source packages to the community. Speaking of which, if you're watching this and you're not a Flutter Bounty Hunter, well, thank you for watching. Thank you for sticking around to the end. I appreciate it. If you're an experienced Flutter or Dart developer and you'd like to be a Flutter Bounty Hunter, go check out Flutter Bounties on Twitter. There's a link to an application in the bio. Also, if you're a team or a company that would like to utilize our services to build an open source tool that your company and other companies can use, go to flutterbountyhunters.com and shoot me a message, or you can find me on Flutter Bounties and send me a direct message. I'd love to get a project set up and get some milestones funded that help your team or your company. So with that, please hit the subscribe button if you'd like to stay up to date with this channel. And y'all come back now, you hear?